Hello! Today we're going to learn about number theory. Yep. And what number theory basically is the study of integers. Like 0, 1, 2, 3, and so on. And today we are going to, here we go. And today we're going to learn how important and how useful this number theory is to our real life. Such as, number theory can be used to save the New York City. Have you ever imagined?
Be careful. Don't open it.
What? I gotta open it. It's gonna be all right.
Shit! I told you not to open it!
I trust you see the message. It has a proximity circuit, so please don't run.
Yeah, I got it. We're not gonna run. How we turn this thing off?
On the fountain there should be 2 jugs. Do you see them? A 5-gallon and a 3-gallon. Fill one of the jugs with exactly 4 gallons of water and place it on the scale, and the timer will stop. You must be precise. 1 ounce or more or less will result in detonation. If you're still alive in 5 minutes, we'll speak
Wait
again.
a sec! I don't get it. You get it?
No.
Get the jugs. Obviously, we can't fill the 3-gallon jug with 4 gallons of water, right?
Obviously.
All right, I know. There we go. We fill the 3-gallon jug exactly to the top, right?
Uh-huh.
Okay, now, we pour that 3 gallons into the 5-gallon jug, giving us exactly 3 gallons in the 5-gallon jug, right?
Right.
Okay.
Then what?
Now, take the 3-gallon jug, we fill that a third of the way
No,
up.
he said be precise. Exactly 4 gallons.
Copping 50 miles is running his ass off, and I'm out here playing kids' games in the park.
Hey! You want to focus on the problem at hand?
So we need to save the New York City from bombing up. And here I have these miniature figures of what we have seen in the movie. This represents the 3-gallon jug, and this represents the 5-gallon jug. I hope you can see this because I can't really see the screen from here. And these little balls each represent 1 gallon of water. And our job is to fill up this jar with 4 gallons of water without using any other tools except these 2 jars. So, does anybody have an idea of what we should do? Sean? Let's have a try. It's hard.
It's full? Both?
No, they're both empty.
아.
여기 있으면 안 돼.
응?
Mm-hmm. Give up? So I'm back, and Sean gave up. Let me give a possible solution. Look. So you first fill the 3-gallon jar, and then you pour that into the 5-gallon jar. And you will have 3 gallons in the 5-gallon jar. And then you pour back 3 gallons more into the 3-gallon jar, and you pour this in, which leaves you with 1 gallon, right? And you throw this away. And now you have 1 gallon here. And you pour that into the 5-gallon jar. Do you get it so far? And then you pour 3 gallons into the 3-gallon jar. And then you pour that into the 5-gallon jar and you get 4 gallons. Ta-da! Oh. How do you feel? So now we're going to see how to solve this problem using the number theory. And for that, we're going to use a theorem from the number theory called the abstract prime number theory. Prime number theory. I'll just leave it like that. Maybe I should write a bit smaller. Anyways, what this theory says is that suppose there are 2 jars of P and Q gallons in which the P is smaller than Q gallons respectively, and suppose also that P and Q are relatively prime. Note that the two numbers are called relatively prime if their greatest common divisor is 1. Okay? So if this is fulfilled, then for any integer k in which k is smaller than q, there are integers m and n such that mp plus nq equals k. Okay, so this is a theorem from the subject of number theory, and we won't prove it here, but we will interpret it in the context of our problem. So if n and m is negative, this means we are applying a jug, we are emptying a jar of P or Q gallons respectively. And similarly, if m and n is positive, then this means we are filling the jar of P or Q gallons respectively. And for example, suppose that, let me rewrite it here, mp plus nq equals k. Suppose that P equals 3, Q equals 5, and K equals 4. This will be like our problem, right? So in this case, we will have 3m plus 5n equals 4. And here we can easily see that 3 times 3 plus 5 times negative 1 equals 4. So we can solve the 3 and 5 jar problem to make 4 gallons by filling up the 3-gallon jug 3 times and emptying the 5-gallon jug once. And if you notice, there is another solution to this problem, and that is this. And this also makes sense. So you can achieve 4 gallons by filling up the 5-gallon jug twice and then emptying the 3-gallon jug twice, and you will have 4 gallons left over. This highlights the problem and shows that we must have jars with relatively prime capacity to achieve the task. For your information, we'll see that if P and Q are not relatively prime, in other words, if their greatest common divisor is not 1, then any such combination MP plus NQ will have the divisor given by the greatest common divisor. And it could have other divisors as well. So now we have an application of a theorem of abstract number theory to a practical problem of capacity and achieving a certain volumetric measure. This is higher mathematics at work. The end.